This is 5.5, and today we're going to talk about inequalities in triangles. The first part of this chapter has been all about things being equal with angle bisectors and perpendicular bisectors. This is going to talk about inequalities, so when things aren't equal. And usually when you're talking about inequalities, you're talking about greater than or less than. You're talking about things being bigger than somebody else. So the first one is, I just asked kids, draw an obtuse scalene triangle. So obtuse scalene, maybe something like that. I know it's obtuse because this one's going to be 95 degrees, so I know it's bigger. And scalene just means that all of these have to be different. Okay? Find the largest angle. That would be this guy right here. We'll put some labels on there. So the largest angle is angle B. The longest side would be this guy. So AC. Longest. Then it says find the smallest angle. So this guy's going to be the smallest one, angle C, and then AB will be the smallest side. And the reason kids kind of know that, or where they kind of get that from, is besides just looking at it, is that big angles have big sides. So the wider that angle opens up, the bigger the side is going to be. The smaller the angle, the smaller the side. Okay? So small angles always go with small sides, and big angles always go with the biggest sides. So the first theorem we're going to say is if one side of a triangle is longer than another, then the angle opposite, which is what we're talking about. Okay, so if one side is longer, then the angle is going to be bigger. Then the angle opposite the long side is larger than the angle opposite the small side. So if I know that AB is 8 and BC is 5, I know the angle across, so angle C, is bigger than A. If this angle's got a bigger side opening, an 8 is bigger than a 5, so the C angle is bigger than the A angle. The converse is also true, just kind of, I shouldn't say converse, it also works for angles as well. So if one angle of a triangle is larger than another, then the side opposite, the larger angle, is longer than the side opposite, the smaller side. Smaller angle, sorry. So this is kind of saying reverse. If I know the angles instead, so if I know angle C is 30 degrees and angle A is 50, then that makes BC longer than AB. This is the longer side to the 30. Okay? So what you're going to be doing today is figuring out which one is smallest to biggest or biggest to smallest. You're going to list them. So we're going to list the sides. I'm going to start with the angles because sometimes that helps me better. So angle R is the smallest at 29, I think that is. And then you've got angle T and then angle S. So small, medium, large. So now your sides are what's across from that. So across from R is ST. That's the shortest side. Across from 30 is RS. That's the second longest. Across from S is RT. So now I've got all three sides going from smallest to largest. One more little theorem. It has to do with adding up two sides of a triangle. So the sum of any two sides of a triangle is greater than, has to be bigger than the third side. So what that means is if I take, if this is 10 and this is 12 and 5, any two sides, 10 plus 5, 5 plus 12, or 10 plus 12, two of them have to be bigger than the third one. Okay? What you can't have is a triangle like this. 3, 2, and a 1. These two don't add up to be bigger than this side. So what's going to happen is when these two connect to each other, they'll be the same length as this guy. So they won't actually prop up and make a triangle, they'll just fall down. So any two of them have to be bigger, greater than the third side, not equal to. That's usually what catches kids, is the equal to. One example that kind of extends that a little bit, a triangle has one side length of 12 and another of 8. So here's 12, here's 8. We're trying to find out the third side. There are two different triangles that could happen. It could be like this, where this guy is the biggest side, or it could be like this, 12 and 8, and this guy is the smallest side. Two different things could happen. So we're going to set up two different problems, and then we'll kind of combine the two of them, okay? So in this case, if this guy is the biggest side, then that means that 12 plus 8 have to be greater than it, because any two sides have to be bigger than the third one. So if this guy is supposed to be the biggest, then these two have to be bigger than it. So 20 has to be, well, x has got to be less than 20. The other way around, if this is the smallest side, then the smallest plus the medium has to be bigger than the biggest, which would be 12 this time. So if I subtract 8, then that means x has to be greater than 4. So anywhere between 4 and 20, any of those side lengths would make me a third side that would be legal. If I pick 4, then 4 plus 8 is 12, and you can't equal, you have to be bigger than. If I pick 20, then 12 plus 8 is 20, and it's got to be greater than. So that's why there's no equal underneath. This is all got to be greater than or less than, okay? So just watch when you're doing this one. We want to set up two different cases, one where it's kind of the biggest side or one where it's the smallest side. Some kids do, I got to add these and then I got to subtract them, which is literally what you're doing.